start with a number that's almost impossible to truly wrap your head around. Every single night, next-generation telescopes like the Vera Rubin Observatory in Chile, which began its survey in 2025, capture over 20 terabytes of data. What does that even mean? A single terabyte is 1,000 gigabytes. A typical high-definition movie is about 3 or 4 gigabytes. So 20 terabytes is the equivalent of watching over 6,000 HD movies. Now, imagine your job is to watch all 6,000 of those movies. That's over 12,000 hours of footage before sunrise. And you have to spot every single tiny, fleeting detail that might be a new asteroid, a dying star, or a planet being born. It would take a single person watching 24/7 without a break, more than a year to get through one night's worth of data. And that's just one telescope. NASA's missions collectively generate petabytes of information annually. That's thousands of terabytes. The upcoming Square Kilometer Array, a colossal radio telescope network, is projected to generate more data in a single day than the entire global internet traffic. We have built instruments that can see farther and deeper than ever before, but in doing so, we've created a cosmic ocean of information so vast that no team of humans, no matter how brilliant or dedicated, could ever hope to swim through it. We are, quite literally, drowning in the universe's secrets. This is where AI steps in, not as a replacement for the human mind, but as our indispensable cosmic guide. Think back to 1930. The astronomer Clyde Tombaugh discovered Pluto by sitting in a cold, dark observatory for months, painstakingly comparing photographic plates of the night sky, using a device called a blink comparator. He was looking for a single, tiny dot that had moved ever so slightly against the background of stars. It was a monumental feat of human patience and dedication. Today, an AI can perform that exact task, scanning for moving objects, comparing images, and flagging anomalies across the entire sky in mere seconds. But it doesn't stop there. While looking for the next Pluto, it's simultaneously searching for the faint flicker of a supernova, the subtle wobble of a star indicating a hidden planet, and the unique radio signature of a distant galaxy. It's like giving every astronomer on Earth a team of 1,000,000 tireless, brilliant research assistants who never sleep, never get bored, and can see patterns that the human eye and brain simply evolved to miss. This isn't just a problem for astronomers. We all live in our own personal data deluge. Think about your phone. The constant stream of emails, notifications, social media updates, news alerts, and messages. It's an endless fire hose of information, and most of it is noise. We suffer from decision fatigue, struggling to figure out what actually needs our attention. We scroll endlessly, feeling busy but not productive, because we're manually sifting through our own data for the things that truly matter. Now, imagine an eye not just for space, but for your life. An intelligent filter that doesn't just sort your emails into folders, but understands your long-term goals. It could analyze your communications and tell you, hey, this message from your old mentor aligns with the career change you were thinking about last month, while filtering out the 50% off coupon for a store you never shop at. AI in space exploration is teaching us a powerful lesson. We need tools to help us find the signal in the noise. What if you could apply that principle to your own life? What if you could use technology not to add more distractions, but to strip them away, freeing you to focus your energy on the people, goals, and passions that are your own personal cosmic discoveries? Now, let's zoom out from our own lives to the grandest search of all, the hunt for other worlds. The search for exoplanets, planets orbiting distant stars, is at the heart of our quest to know if we're alone. For decades, it was pure speculation. Then came missions like NASA's Kepler Space Telescope, which changed everything. Kepler stared at a single patch of sky for years, monitoring the brightness of over 150,000 stars, waiting for a telltale sign, a tiny, periodic dip in a star's light, indicating a planet was transiting or passing in front of it. But these signals are incredibly faint. A planet the size of Jupiter passing in front of a sun-like star causes a dip in brightness of only about 1%. That's already tough to spot. An Earth-sized planet? The dip is a minuscule 0.01%. It's the astronomical equivalent of trying to detect a fruit fly momentarily dimming a massive stadium searchlight from 100 miles away through a hazy atmosphere. Human astronomers looking at these light curves found thousands of planets, but they were trained to look for clean, predictable dips. The universe, however, is messy. Stars have sunspots that cause their own dimming. Sometimes multiple planets are in the same system, creating a complex, overlapping pattern of dips. In 2018, researchers at Google decided to unleash an eye on the Kepler data that had already been analyzed by humans. They trained a neural network on confirmed planet signals, teaching it what a real messy transit looks like. The result? The AI immediately identified two brand new exoplanets that had been completely overlooked. One of them, Kepler 9OI, was the 8th planet discovered in its system, making it the first star known to host as many planets as our own sun. This was the watershed moment. Today, AI is the backbone of exoplanet hunting. The test mission, Kepler's successor, is scanning nearly the entire sky, generating a torrent of data that would be impossible to analyze without an eye. In a breakthrough in early 2025, a sophisticated deep learning algorithm, poring over test data, uncovered a stunning system of 7 rocky Earth-sized planets orbiting a nearby star. What was remarkable was that several of these planets were located squarely in the habitable zone, the orbital sweet spot, where temperatures could allow for liquid water to exist on the surface. The AI succeeded because it didn't just look for simple dips. It recognized a faint, complex, harmonic rhythm in the star's light, a subtle dance of multiple planets that human analysis had dismissed as stellar noise. Why it matters? The search for habitable worlds taps into one of the deepest, most fundamental human questions. Are we a unique miracle, or is the universe filled with life? Every time an eye helps us find a rocky world in the habitable zone, it's not just a data point. It's a potential answer. It's another place marker on the cosmic map that says, look here, this could be another Earth. AAE is our primary tool for finding potential cosmic neighbors, transforming a question of philosophy into a statistical probability. This search for faint signals in a noisy universe has a powerful parallel in our own lives. Think about your career, your relationships, your personal growth. The biggest opportunities aren't always the loud, obvious ones, the big promotion announcement or the dramatic life event. More often, they are the subtle, recurring patterns. The quiet colleague who consistently offers insightful feedback. The small hobby that brings you a disproportionate amount of joy and calm week after week. The gentle gut feeling that a certain path, while not the most glamorous, is the right one for you. These are the hidden planets in your personal universe. They are faint signals that can easily be dismissed as noise in the chaos of daily life. AI's success in finding exoplanets teaches us the value of precision and paying attention to the small details. What if you trained yourself to look for these subtle signals in your own right curve? What tiny, recurring patterns of joy, opportunity, or connection are you currently overlooking because you're only looking for the big, obvious events? Let's bring our journey closer to home, at least in our solar system. We're on the dusty, rust-colored surface of Mars, following the tracks of NASA's Perseverance rover. For decades, operating a rover was a slow, frustrating process. Scientists on Earth would see an interesting-looking rock, then spend hours planning a set of commands. Drive forward 10 meters, turn 15 degrees right, point camera. They'd send the commands, then wait. Because of the vast distance, our ADIO signals between Earth and Mars can take anywhere from 5 to 20 minutes to travel one way. That's a 40-minute round trip for a single command and its confirmation. Imagine trying to drive a car with a 40-minute lag on the steering wheel. It's painstakingly slow and inefficient. Perseverance is different. It's equipped with an AI system called AGIS, which stands for Autonomous Exploration for Gathering Increased Science. AGIS acts as the rover's science-savvy brain. As Perseverance drives, its cameras are constantly scanning the Martian landscape. The AI analyzes the images in real time, comparing rock shapes, colors, and textures to a database of what geologists find interesting, things like veins of quartz or specific crystalline structures that could indicate the past presence of water. When a AGIS spots a match, it can make a decision on its own without waiting for Earth. It can stop the rover, point its high-powered ChemCam instrument at the rock, and fire a laser to analyze its chemical composition. This autonomy has allowed Perseverance to make more discoveries more quickly than any rover before it. This is just the beginning. The Europa Clipper mission, launching in the late 2020s to explore Jupiter's icy moon Europa, will face an even greater challenge: intense radiation. It can only make brief, daring flybys of the moon. AA will be critical for making split-second decisions about which parts of the surface to scan, prioritizing scientific targets on the fly. Even more ambitious is the Dragonfly mission, a nuclear-powered rotorcraft set to launch for Saturn's moon Titan in 2027. Titan has a thick, hazy atmosphere and a surface of frozen hydrocarbons. Dragonfly will fly from site to site, like a drone on Earth. But with a round-trip communication time of nearly 3 hours, it must think for itself. Its onboard AI will be responsible for analyzing weather patterns, selecting safe landing zones, and identifying scientifically promising locations to sample. This marks a profound evolution from the Apollo era, where thousands of human computers did calculations back in Houston, to an era where the cognitive load of exploration is increasingly handled by the explorer itself. Why it matters. AI-powered spacecraft represent the next leap in our ability to explore. They can go to places too distant, too dangerous, or too unpredictable for constant human supervision. This autonomy isn't about replacing human scientists. It's about empowering them. By letting the AI handle the driving and the immediate targeting, it frees up the brilliant minds back on Earth to focus on the big picture. What does this discovery mean? Where should we go next? What is the story this world is trying to tell us? This trend of intelligent autonomy is mirrored directly in our daily lives. Think of self-driving cars, smart thermostats that learn your schedule, or financial apps that automatically categorize your spending and suggest a budget. These aren't just conveniences. They are tools for cognitive offloading. Every repetitive, rule-based task you can automate is mental bandwidth that you get back. In your own life, what tasks are you performing on manual control that could be automated? Are you manually sorting receipts when an app could do it? Are you constantly checking your calendar when you could set up intelligent reminders? Embracing automation isn't about becoming lazy. It's a strategic choice to delegate the mundane so you can free up your uniquely human intelligence for creativity, strategic thinking, deep connection, and problem solving. What repetitive tasks could you automate this week to free up a few hours to work on your bigger mission-critical goals? In April 2019, an image was released that stunned the world. It was a fuzzy, glowing orange ring, a halo of superheated gas surrounding a perfect circle of pure blackness. This was it, the first ever direct image of a black hole shadow, located 55 million light-years away in the M87 galaxy. Seeing it felt like staring into the abyss, at the very edge of reality. But this image was not just a triumph of telescopes. It was a masterpiece of artificial intelligence. The telescope that took the picture, the Event Horizon Telescope, EHT, wasn't a single dish. It was a network of 8 radio telescopes scattered across the globe from Hawaii to Spain, from the South Pole to Chile, all synchronized to act as one virtual Earth-sized telescope. But even with a telescope the size of our planet, there were huge gaps in the data. The telescopes could only gather a tiny fraction of the light. Project lead Dr. Katie Bowman famously compared it to trying to solve a puzzle with 99% of the pieces missing. This is where the AI came in. Her team developed several algorithms, including one called Chirp. This algorithm didn't just try to guess the missing data. Instead, it behaved like a brilliant police sketch artist with a photographic memory for physics. It generated millions of possible images of what a black hole could look like, based on Einstein's equations. Then it meticulously compared each of these theoretical images to the sparse, fragmented data the telescopes had actually collected. It asked, does this image fit the evidence? Images that didn't fit were thrown out. Images that did were kept and refined. Over time, by running these millions of tests, all the different algorithms began to converge on a single, consistent image, the glowing ring of fire we all saw. In 2022, the team did it again, this time imaging Sagittarius A*, the supermassive black hole at the center of our own Milky Way galaxy. This was even harder because gas swirls around it so quickly that its appearance changes in minutes. The AA had to account for this blurring effect, reconstructing a coherent image from a rapidly shifting target. It was an eye that allowed us to pierce the veil and see the invisible. Why it matters? The black hole image is a landmark achievement of human-AI collaboration. It demonstrates that our most profound discoveries will come not from humans or AI, but from the two working together. Human curiosity asked the impossible question. Human ingenuity built the global telescope, and artificial intelligence provided the computational power to make sense of the answer. It's a powerful reminder that with the right tools and a creative approach, even the most seemingly impossible challenges are within our grasp. Everyone has a black hole in their life. It's that one problem or goal that feels so huge, so daunting, and so unclear that you don't even know where to begin. It could be a major career change, starting a business, or healing a broken relationship. It feels like a void, an unsolvable puzzle with too many missing pieces. The story of the EHT gives us a powerful framework for tackling these black holes. First, gather the data you have, no matter how sparse. What do you actually know for sure about your problem? Write it down. Second, use your imagination to generate possibilities. Like the AI creating test images, brainstorm all the potential paths forward, even the crazy ones. Third, test those possibilities against your data. Which path best aligns with your skills, your resources, and your values? Use your tools, mentors, books, small experiments to fill in the gaps. Just as an eye pieced together scattered light to reveal a cosmic monster, you can piece together small actions, bits of knowledge, and support from others to make your most intimidating challenge manageable and eventually conquerable. We now arrive at the most profound question of all, the one that has haunted our dreams since we first looked up. Are we alone? The search for extraterrestrial intelligence, SETI, and the broader hunt for biosignatures, the chemical signs of life, is a cosmic detective story of the highest order, and AI is its lead investigator. The Breakthrough Listen Project, the most comprehensive SETI search in history, scans billions of radio channels from 1 million nearby stars. The sheer volume of data is staggering. The challenge is to distinguish a potential intelligent, structured signal from the overwhelming cacophony of natural cosmic noise pulsars, quasars, and our own Earth-based interference, like cell phones and satellites. In 2023, their A system, trained to spot signals that don't look natural, flagged several dozen intriguing signals of interest that warranted a closer look. While none have yet been confirmed as extraterrestrial, the eye is proving its ability to find the proverbial needle in a galactic haystack. But an eye isn't just listening for aliens. It's looking for life in any form. The James Webb Space Telescope, which became operational in 2022, can analyze the light passing through the atmospheres of distant exoplanets. By looking at the spectrum of that light, scientists can determine what an atmosphere is made of. AI algorithms are now being deployed to sift through this spectral data, searching for biosignatures. For example, an atmosphere rich in both oxygen and methane would be a huge red flag, as these two gases normally destroy each other. Finding them together could be a strong indication of an active biological process, like photosynthesis and metabolism. Perhaps AI's most important role in this search is its ability to think outside the human box. We tend to look for life as we know it. But what if life on another world is based on a completely different chemistry? What if an intelligent signal is not a neat repeating radio pulse, but a complex mathematical pattern we wouldn't even recognize? An AI free from human biases and preconceptions can be trained to look for one thing and one thing only: anomaly. It looks for patterns that don't fit our known models of physics and chemistry. In doing so, it might just find the very thing we weren't smart enough to look for. Why it matters. The search for life, whether intelligent or microbial, is fundamentally a search for context. Finding it would reframe humanity's entire existence. It would mean we are part of a larger cosmic story. AI's role in this is to be our impartial, open-minded scout, pushing us beyond our assumptions and forcing us to consider every possibility. How often in your own life do you operate with a fixed set of assumptions? We all have biases that shape our worldview. We dismiss an idea because it sounds strange. We judge a person based on a first impression, or we avoid a path because it's not what people in our circle normally do. This is our human bias at work. AI's unbiased search for anomalies is a beautiful metaphor for the power of genuine curiosity and open-mindedness. It challenges us to listen to perspectives we disagree with, not to find flaws, but to genuinely understand. It encourages us to try that hobby that seems weird, or to talk to that person who is completely different from us. What unexpected discoveries might you make if you deliberately stepped outside your intellectual and social comfort zones? What anomalous signal in your life, an idea, a person, an opportunity have you been dismissing that might just hold the key to a major breakthrough? The partnership between artificial intelligence and space exploration is still in its infancy, yet its impact is already revolutionary. From finding new solar systems to navigating alien worlds and imaging the unimaginable, AI is acting as a powerful amplifier for human curiosity. Looking ahead, the synergy will only grow stronger. As we discussed in our previous episodes, the future fusion of AI with the immense power of quantum computing could unlock possibilities that sound like science fiction. Imagine a quantum AI that can simulate the formation of a galaxy in perfect detail, or run millions of scenarios to pinpoint the exact conditions that led to the Big Bang. The next generation of telescopes, spacecraft, and algorithms will exist in a collaborative ecosystem. The Vera Rubin Observatory will flag an anomaly, and AI will analyze it in seconds. A network of autonomous telescopes will immediately pivot to get a closer look, and a mission like Dragonfly 2.0 will be dispatched to investigate it on the ground. This isn't just about finding answers to our current questions. It's about building a system that can discover and ask questions we haven't even thought of yet. This journey is not just about the cold, hard data of distant stars. It's about the very human drive to explore, to understand, and to grow. AI is our partner on this grand adventure. The story of AI in space is a testament to the power of a virtuous cycle. Embracing new tools leads to new discoveries, which in turn inspire the creation of even better tools. You can create this same cycle in your own life. What's one new skill, one piece of technology, or one new perspective you could adopt? Maybe it's learning to use a project management app, taking an online course, or starting a meditation practice. That new tool can unlock new potential, giving you insights or freeing up time, which then inspires you to take the next step on your own journey of growth. The future is yours to explore one click at a time. If there is one thing to take away from this cosmic journey, it's this: no challenge is too vast, no mystery too deep. When we combine our innate human curiosity with the right tools, AI in space teaches us that the key to solving the impossible is to break it down into manageable pieces, to use technology to amplify our own strengths, and to remain radically open to possibilities we can't yet see. Just as our eye helps astronomers find the light from hidden worlds, you can use the tools around you, a simple app, a conversation with a mentor, or a quiet moment of reflection to uncover the extraordinary hidden opportunities in your own universe. Now, I want to hear from you. Drop a comment below. What single space mystery would you want to point an advanced AI at? Is it proving the existence of dark matter, finding a truly Earth-like planet, or finally getting an answer from a SETI signal? Let's get a cosmic conversation going.